purple hue to it is like what I thought was fluoride.
The sheeted veining and the lamphophyre with the northeast and this is defined by the geochemistry mostly.
Yep.
And so if we can find out where the main structures are and have evidence of sheeted vein systems in proximity to that.
A number of us have been flown into this prospect camp here in the Yukon, and the objective is to try and determine as accurately as possible what the geology is of the system, what the potential is, and that sort of thing. So we're here just getting started on this. What I want to do initially, we're start off with the core, which is not the ideal spot to start. What I tend to like to do is, or what makes more sense, is start from the outside of an alteration system, a mineral system, see what the rocks look like out there. And as you move into that system, you start to see the changes, the alteration, what's happened to the rocks, the minerals, to make them mineralized. And so that's what we're looking at here. We're right in the guts of this thing now. Samples along here, this sample in particular, this meter-long sample is running about 24 grams a ton gold, which is very high grade, but the object here is to put this into context. And that's what we do on these field trips, is try to put what you're seeing in drill hole results, in sample results, in press releases, into context with what's really going on here. So what I want to do on this excursion, if we can pull this off, is move back from this up into the hills and see what the rocks really look like, and then come back in and focus on what we've really got here. So what we've got here is a few boxes of drill core, and the drill comes out as a tube like this, and then it's split or broken in half as best they can to something like this, where you can see the half core is gone. This half gets sent off to the assay lab. This stays back for the geologists and such to do the geologic interpretation. The most obvious thing that anyone you can see looking at this is the color variations. We're going from gray to white. We've got rust colored. We've got oranges. All these different colors are telling us that different things happening. And what we need to do is determine which is important, what's the important aspect of it or not. This material here is fresh, essentially fresh. It's been baked, but it has not been altered or mineralized. And I can tell that just, we know the assay, so I know it hasn't really been mineralized. This is essentially the same rock as this, but this has been altered and mineralized. Hydrothermal fluids have come in and changed this from this rock to this rock, introduced sulfides, and it's been oxidized. That's what this color amounts to. This sample here actually runs 98 grams a ton, which is extremely high grade. But you want to look at, it's that wide, or you could take it to here, I suppose. So we've got about a meter running 98 grams per ton. Again, we need to take that back into context. How much does that really reflect onto what the whole system is? And we're going to be up on those hills up there and trying to put the geology together of, again, context, all that context, tons and grade. So what we've got here is something happening to the rock we just looked at. Here you can see clasts, these gray clasts within a wider matrix. This is called a breccia. It's a hydrothermal breccia, meaning the fluids have been, hydrothermal fluids have come through and moved the rock around to make it in this shape. And that often is the sort of thing you get accompanying mineralization. The more violent the movement, the more opportunity there is for gold or whatever to precipitate out. Interesting sample. It's a massive sulfide piece of core. It's probably about, maybe only that wide, this long or thick. The lighter gray is a pyrrhotite. The darker gray is a arsenopyrite. And then we've got this one streak right through here. That's copper, chalcopyrite. And this is what their gold is running with, is with mostly with the arsenopyrite, the gray material. Moving back to this is about essentially the same rock. And what happened here, we've oxidized it, or turned it to rust. And this oxidation process is something you hear a lot about when people are talking about mineralization. The importance of oxidation is what it's done is turned the sulfide into rust, and when it turns to rust, the gold is liberated. That's what makes it so much more economical or cheaper to process the ores. You don't have to go through the process of turning this into this.
It goes all the way to Keno, all the way over to Brewery Creek.
Passes through here?
Yeah, it's.
That doesn't match.
I'm not real sure.
All right, we've left the camp where the core is taken down to and cut, mapped, logged, and sampled. And that's where we looked at the different rock types and we talked about trying to put these into context of what we're at. This is one of the holes right here, marks one of the holes we drilled. And what we're chasing here, if you can look out to that side, that ridge is cut by a vein set that's running sort of like this. And this drill hole and the one just down there is focused on trying to intersect this set of veins coming in from this direction, just like that. And in the core, remember we saw the gray rocks, the red rocks and that? You can zoom up on this. This gray rock I just picked off the ground here is much the same as we saw in the drill core. So we can see what we're drilling into is mostly this sort of rock, and we're hitting the vein sets that I talked about earlier, and that's where the alteration and mineralization is coming in. And our objective here is to get a sense of how those vein sets that we talked about coming across this direction relate to what the company has mapped as a series of gold geochemical anomalies in soils that tend to run like this. So it's this intersection of this vein set, which is dipping like this, and the soil geochemistry that's running like this. That there is their target. And you can see this drill rig down here, which is what they're drilling towards again. Right now, so now we're looking out into the distance, and what I tried to explain before is there's this sheeted vein system running like this. If you envision the mineralization, the gold in the quartz veins, sitting in a sheet that dips like this, if you look at, you always have to, whenever I come to an outcrop or a mineral prospect, from the first rock I pick up, it's about what's it really going to cost to put this into production, what are the issues we have to deal with. Now if we've got a sheeted vein system sitting like this, and we're thinking of building an open pit into this, you can see that all the rock on top of us, all this that we're seeing to the top of the hill, this is waste rock. That's got to be moved before we can get to this mineralized material. That's an extra cost if we're going to do this open pit. The other option is if we can get high enough grades, then we can go underground on that. And in that case, this is a good setting because you've got the hill like this. You can come into the hill like this, into the vein, and it's much cheaper to drop the material down rather than move it up. So if we can get high enough grade, or if this company can get high enough grade that these veins can be mined underground, they're in better shape, as opposed to having to move the top of the mountain to pull an open pit. So the actual physical setting, the topography of this sort of deposit, the mineralization, the way it sits on the hillside, these are all the sorts of things that you don't get a sense for, or generally don't get a sense for, sitting in an office, going over maps, or reading press releases. Likewise, if you don't come and look at these things, you never really know what the issues might be, what the positives and negatives are. That's why it's critical to get out into the field and evaluate a property, especially early stage property, as quickly as you can, because now we've got a sense of what the costs are going to be to put something into production if they drill a decent drill hole.
Brent, when you look at a sheeted vein system like this, and specifically if we look at this outcrop, how pervasive would you expect this sheeted system to be? Are we looking at 1 or 2 or 4 meters, or could we be looking at 50 or more meters of sheeted veins? And as a follow-up question, if you look at this sheeted vein system, we can look right through the road and you can pick up the little veins, and you'd expect them to continue along strike for quite some ways. So how would you mentally go about thinking about a system like this in terms of the bulk tonnage potential?
From my experience, a sheeted vein system really amounts to a bulk mineable target. That's what Fort Knox is. That's what Cisco is these sheeted vein systems. And these are, you know, average out about a gram. To get that to work as a bulk mineable deposit, you need, you know, 50, 100, 200 meter wide widths across decent strike lengths of, again, 400 to 500 meters to pull this into a big pit that's economic enough. And looking at this, as we've been looking at, the number of veinlets through there gives you a sense of how much gold there's going to be. And we need a lot of veins through here. This is questionable in my mind. This is questionable where this is going to bulk up into something that's workable. When people are talking about sheeted vein systems or stockwork systems, similar sorts of things, it's a bulk mineable deposit. And the idea is that although the veinlets themselves aren't particularly economic, at least for the old timers in high grade, if you can bulk that up into a large enough deposit, the scale of mining makes it cheap enough that you can mine down to 1 gram or even less, depending on, you know, a lot of other factors. So looking at this outcrop, you can see that there's a number of veins like that, but it's not very tight. We're looking at maybe 6 per meter. So the veinlets themselves have got to carry a fair bit of gold. And as well, bulk mineable deposits, you need to extend something this over 100 meters width plus by maybe 500 meters along strike to come up with the tons, or the ounces, that'll pay for the heavy equipment and the mill and such to process this sort of thing. So if they can't demonstrate that this thing is not just here running a gram or better, probably better than that, but a gram over there, 500 meters that direction where we looked at some core from previously, it just flat out doesn't work.
Are there any indications from looking at an outcrop like this as to how pervasive the mineralization might be or the system might be? Can you make any deductions as to the potential of a system by looking at as small of an outcrop as we're looking at here?
Not really. It's tough. I think what you need to do in these things is come from the outside, see what the unaltered rocks look like, and work in to see what's happening to those rocks to get a sense of how strong the system is. It's all about how strong a system is, and that's key. So many people come to an outcrop and evaluate a property based on an outcrop. And unless you've spent, you know, the decades doing this over and over again, you get stuck on the outcrop and you don't get to see what the big picture is. And that's, in my opinion, why so much money is wasted in exploration, is that people get focused on the outcrop and don't consider the overall size of the system. We're back at camp. We've gone through you know, the core, we've seen the site, we've seen the rocks of sort, we've got a feel for the area, and this is the exploration camp where the work is actually put together, where the assays are plotted onto maps, where cross sections are drawn, geologic interpretations happen, and the next drill program is gone through. So as you recall, we started off looking at core. This is the gray core, unmineralized material. Up on top of the hill, we pulled up similar rock. We can see this is the same sort of rock. And then within this zone, the drilling that they were after, to some degree, looks like this. These are the fractures as they're oxidized. So our sheeted veins are sitting like this in this rock. And this is what we're going after. So again, this is this information is all kind of compiled, put into context, plotted on maps like this. These are drill hole traces, and from there sections are drawn and the geologic interpretations happen. And what we've learned here, I think, what I want to try to explain is this: it's a lot more than just reading a drill release or looking at drill results and saying this is good or bad. You have to have all these things in context. What was the angle of the bedding that was drilled? What were the veins look like? How close were the veins spaced? Were the veins in a situation that would be amenable to open pit mining, or do we have to move a whole mountain to get to those things? And we haven't talked about metallurgy, which is key in any sort of mineral deposit. Has it been oxidized? Has it been turned to rust with the gold liberated, making it much easier and cheaper to mine? Or is it tied up with sulfides, requiring more effort, more money, more energy to pull that gold out? These are the things we have to think about. And on top of that, we've got to look at the location. Is it possible to build a mine here? Do you have to haul the ore way outside of camp? All these things add money to these things. So when I started off, when I said, whenever I go to mineral property, I pick up a rock. Just with that first sample, with that first rock type, first assay, you need to build a model, a geologic model in the back of your mind and a financial model in the back of your mind to turn these rocks into money. And that's what it's all about, is turning rocks into money. And you can't do that without the experience and background and visiting these sorts of projects, certainly early stage projects. So these property visits, these site visits where you go and look at these things is why you can see now why it's so important to come to the properties and get a handle on the context of the mineralization, the context of the environment, the topography, all the issues that arise from when you can think about building a mine. It's not just an assay on a news release. And to be quite honest, you cannot do this sitting in an office looking at maps or news releases. And it's not something that a journalist or someone who's an accountant or an economist can really evaluate properly. Mining is a very complex business, as is exploration, and it takes literally decades to get a handle on what's right, what's wrong, what works, what doesn't, and lots of mistakes made along the way. And that's how you learn. And that's why it's, again, so critical that whoever you use for your advice, whoever your advisor is in this, understands the business.